Assalamu alaikum warahmatullahi wabarakatuh. In this part of the tutorial video, we will discuss how to add the washer to the top ring of the skirt, how to add the bottom head nozzle with an elbow, and how to define the projection of the nozzle and the projection of the pipes, and how to add skirt opening and skirt vents and skirt access. Okay, now let's add the skirt washer. So from here, let's select the bottom head, and from here select the vessel, and from here select the shell can, and let's add a connection point as a skirt to make. Okay, and from here let's select it as a shell from a connected nozzle, connected point for a nozzle as a shell. Let's define the diameter of this one, and the thickness will be the same thickness of the can, and let's click on save. And now let's move it between the bottom head and shell one. So from here, let's come from move and move after the bottom head. Okay, now it will be moved between the bottom head and the can one, and now we have an unreal element. It looks like the shell, so we can use it to add the washer or add the skirt vents and access. Okay, now let's select this one, and from the external attachments, let's select the washer. Okay, name it as a skirt washer, and from here you can select it a rectangular or circular washer. So let's select rectangular washer and define the length and the width of this washer. So let's take a look to the washer detail here. It's 140 by 140, and the thickness is 16 millimeters. So from here it's 140, and the width is 140, and the thickness is 16, and the hole diameter, let's check the hole diameter, it's 68. Okay, so from here it's 68, and the bolt circle diameter, it's the same bolt circle diameter here, it's 4168, and the location we can measure it from here. So it's the distance from the tan line to the bottom of this washer. So let's get the distance up to here. So it's 4640. So it's 4640. Okay, and the orientation is 5 degrees, which is the number of holes, like that. So it's 5 degrees, and here let's keep the material like that, and here's the number of the anchor bolts. And now let's click start the assembly to start creating the washer. After that, we will check if the location is and the orientation is correct. If there is any issues, we will remeasure and define it again. As you can see here, the location of the washers come to the up direction, because here we between the head and shell we add a real element here as a shell, and when you define the location with a positive value, it will be moved up. Actually, we need to make the location with a negative value to get it down here. So the location here, we will need to define it with a negative value to move the washers to the other side. Okay, and here, as you can see, here we need to increase this value. I may not measure it in a correct way, so we need to increase this value with 10 millimeters. So we will make it like that. And now let's click start assembly to update the washer location. Okay, and now the washer will be located on the right place. It's a rectangular washer, okay, on the skirt. Now let's add the nozzle F to the bottom head. Okay, so if we take a look to the nozzle information here on the nozzle table, as you can see, it's 16 inches, but it's from plate. It's a nozzle from plate. So how to add a nozzle from plate to the bottom head? From here, let's select the bottom head, and from nozzles, let's select the head nozzle and make it nozzle F. And from nozzle F, let's select a nozzle from plate instead of nozzle from pipe. So let's select from here nozzle from plate and define the outside diameter of this nozzle with the same diameter of the standard pipe. And here the thickness, and here the longitudinal building line orientation, the gap and the offset from the vessel center line. It's on the center, so the offset will be equal 0. And here the material of the plate, we can change it to take the same material of this part as a stainless material plate. And let's put that value here, and we have a rebad. The rebad information, it's the rebad width for F1, it's 180 with 25 millimeters thickness, 180 with 25 millimeters thickness, and here's the rebad material, and the name of this one is outlet nozzle, and keep on save. The projection, we will keep it right now until adding the elbow to measure the projection in a correct way. As you can see here, if we take a look to the right side here, the projection of this nozzle, okay, measured from the tan line, and here we have this center line from after adding this elbow. So let's add the elbow first. So if elbow, okay, and from here let's select that elbow and select elbow 90 degrees long radius and define the size is 16. And here's the thickness of this elbow is user defined thickness is 10 millimeters, and the orientation we will keep it at 0. And now if we come back to the nozzle, and from the calculator we can calculate the projection. Here it's 1800 from the tan line. So if we take a look to the image here, in SEG the definition measured from the seam line. So we will need to add more 50 millimeters for the straight flange. So the total value will be 1850. So from here, let's click on calculate to calculate the required length. In that case, SEG will create a sketch to calculate the actual pipe projection. So when you click on save, now you will get that elbow. So when you click on start assembly, you will start creating the nozzle as a nozzle from plate. So the neck will be from plate, so you can get plate development for this part and the rebad for this nozzle. Okay, so let's take a look from the front view. Okay, and take a look from here. Now we have this nozzle with that elbow. Now let's come back to the AutoCAD drawing, and here we have two pipes. Pipe from plate, it's not a standard pipe. So the first pipe length is 283, and the second pipe length is 1250. Okay, so now let's add two pipes. So from here, let's select the external connection point, and let's add F pipe 1. Okay, and from here, let's select shell, and in that shell, let's define the or select a welded pipe. So we can select the size of this pipe. It's a welded pipe, so it's 16 inches. And from here we can define the thickness. So it's 10 millimeter the thickness, and the length is 283. So it's 283. And from here the longitudinal building line orientation, we could keep it 45, and the gap as 2. Now let's add another pipe, which is F pipe 2. Okay, and click on we could make it looks like pipe 1, and from here we can change the length. it's 1250, and the orientation we can change it as 135 and click on save. Now let's add the last part on this nozzle, which is this flange. So let's come here and from elements let's add a flange. So if flange. Okay, and this flange we will define it as a weld neck raised face according to ASME P16.5 with rating 150 and the size is 16, and the schedule we will remove it and define the thickness as 10 millimeters at the end and click save, and we can define the material as we discussed by typing it on this text box or getting it from the material library. Now when we click on start assembly, we will start creating the first pipe, which is connected to the elbow, and the second pipe with the other longitudinal building line, and here finally the nozzle with the flange. So as you can see, we have this nozzle goes outside the skirt. Now we need to add a skirt opening to this skirt. Okay, so how to make an opening on this skirt? Okay, so let's come back to the AutoCAD drawing. Here we have a skirt opening one, SO1. So let's check the size of this one on the nozzle table. It's SO1. So the inside diameter is 617. Okay, and with the thickness 24 millimeters. Now let's select the skirt connection point to use it to add nozzles, and select nozzle type B, which is give you the ability to make a nozzle with internal and external projection. So we can use this type of nozzle to make skirt vent, skirt access, and skirt opening. Now let's select it and SO1 like that, and from here let's select it as a nozzle from plate and select the pipe OD. So the pipe OD, so let's calculate the pipe OD. It's 617 plus 48. So that's the outside diameter of the pipe. So that's the OD, and the thickness is 24. And let's keep the orientation as 42. And the location, as mentioned, we need to add the location with a negative value. Okay, and this value measured from the seam line. So here the value is 1,800. So we will need to define this value as a negative 1,850. We need to add the straight flange value here, and we will give it the orientation of the nozzle, and we will need to copy the material. So let's copy the material. It's the plate material, and paste it here. And here regarding the projection, it's a skirt opening. Okay, that's the surface of this one, and the projection we can measure it directly from here. So if you come here like that and measure that one, it's 7.9, and for that one it's 50. Okay, so 7.9. And for the external projection, we can do it by another way, which is if we measure the value from here to there, which is the outside diameter, it's 3. Let's measure it to the center line from here to there. Okay, so we need to add 50 millimeters to that value. So that's the external projection from the vessel center line. So by using the calculator, we can calculate that value directly from the calculator to give us that value. So let's change that value to be like that. Okay, and click on save. Now the projection will be automatically calculated here with 50 millimeters. Now let's run the skirt opening to generate it on the skirt as a nozzle or an opening from plate with 24 millimeters thickness. As you can see, now we have this cut on, this opening on the skirt like that. Now you can make a cut manually to the skirt. So let's go inside the skirt and let's go to inside that part. From here we can select that plan or directly select a sketch and create a sketch here by using the pipe. So from here we have this sketch, so let's make it a construction line, and from here let's make a gap of a cut with 2 millimeters or more if you would like to make it 4 millimeters. So from here let's make extrude cut to next or to next. So the cut, let's define the distance, sorry, let's define the distance as, let's say, 1 meter, for example, and here we have a cut on the skirt for that one. So let's open this one and hide the plan, the work plan. Okay, now we have this cut on the skirt. Let's close this. Now we have the opening on this skirt like that. Now we need to add a stiffening grips on this pipe. As you can see here on this pipe, we have a stiffening plate here. We need to measure the width of this one. It's 80 millimeters, and the height is around 150, and the location from the beginning of the pipe or from the start point of the pipe, it's around 1015. So from here let's select this pipe, which is the second pipe, and from element let's select the external element and select the longitudinal blade. So let's define it as F support blade, and let's click add, and from here let's select a longitudinal blade, define the height. So the height here is 105, and the thickness, let's keep it 10 millimeters, and the location is 1015, and the orientation is at 0, and the width will be 80 millimeters. And from here let's activate the rectangular pattern, circular pattern, sorry, and from here we will add 3 stiffening ribs. Now let's click on start assembly to start creating the stiffening ribs on the pipe. So let's take a look here. So as you can see here we have this stiffening rib. If we take a section on the longitudinal direction like that, so as you can see we have this one, or this stiffening rib, as one more thing, the location measured from the center line of this one, not from the surface. So we need to increase the value. So that value should be, let's measure it from the center of this one. So to be like that, 1055. So it will be like that, and click on save. Now let's start the assembly to update that value. Okay, now the stiffening rib drawn, we draw it in a correct location. Now as you can see we have this skirt opening by that way. Let's remove the cut of the half section, and now let's add the skirt vents. Okay, we have 4 skirt vents from SV1 up to SV4. Okay, and here we have the location and the orientation. Let's check the orientation of the skirt vents. The first one on 45 degrees. Okay, and we have 4 equal vents. So from here let's select a nozzle with internal and external projection. So from here let's add this one. So this is the skirt vent 1. It's so from the nozzle table let's check SV1. Here it's 4 inches with a schedule 40S. So from here it's a nozzle from pipe 4 inches with scalable 40s. Okay, and the location, we will add it with a negative value, 600 plus the straight flange, so it will be 650. So negative 650, and the orientation is 45. And here let's keep that value as it is. And for the internal projection, let's make it 50. And for the calculator, let's make this value, we calculate it. So this one, 22. Okay, so it will be like that. So we can take that, we can keep that one. And you can take a copy from skirt Vint one and make a paste here. Be like that. And just make a rename for the skirt Vint to be skirt Vint 2. And click rename. And you can add one more skirt Vint, which is skirt Vint 3. After that, we can change the orientation for each one after adding them. So let's add the third one, skirt Vint 4. So let's come back to skirt Vint 2 and change the orientation 135. Okay. And finally 350. And now let's run the assembly to add the skirt Vint. After that, after adding the skirt Vints, we will make a cut on the skirt based on the skirt Vint's location. After that, we can add the skirt axis. Here, that's the last skirt Vint. Okay, now as you can see, now we have 4 skirt Vints. So we can make a cut on that skirt based on that one. So from here, let's make a sketch and print the outside line and make another cut. Define the cut gap so we can make it as 2 millimeters. Okay, so from here we can open this part and we can make this plan visible and make a circular pattern for this one along this one with 4 typical parts and close it. So now we can get the skirt Vints along the skirt. Now let's add the skirt axis. Now we have this skirt axis. We have 2 skirt axes, skirt axis 1 and skirt axis 2. And if we come back to the nozzle table and skirt, check the skirt axis, it's the inside diameter, so it's a front plate with 26 millimeters thickness with 450 millimeters inside diameter. So from here, let's select the connection point, and from here select the nozzle with external and internal projection. So skirt axis 1, and for that one, let's select it from plate and define the outside diameter. So here it's defined by the inside diameter 450. So it's 450 plus 26 plus 26. So it's like that. So that's the outside diameter, 26 as the thickness, 45 the location, and finally the location of this skirt axis. It's located on 5130. So we will add 50 millimeters plus that. So it will be 1180. 4180, like that, and the orientation will be on, I think, so it's a skirt axis 1, it's at 180, and for the axis 2 it's at 0 degree. So from here, let's add it on 180 degrees, and the material Let's add the material of the plate, that one. From here, let's add this one and skirt axis. Okay, and click on save, and we can measure the internal projection from here. So let's come down here and measure the internal projection. It's 86, so let's make it 86. And for the projection on the outside, we can make it like that. Okay, and click save. Okay, and now let's we need to add the location with a negative value. I forget to add the negative value, and now let's click save. Now let's take a copy from this one and paste it. Okay, and name it as skirt axis 2. Okay, and click rename to rename it. And now we need to make a refresh and come back to this nozzle and change the orientation to 0 degree and click on save. Now let's run the assembly to create the first and second skirt axis. It's a pipe from a plate with a welding line. And here the second skirt axis. Okay, now we have those axes like that. So let's go inside the can by double clicking on it, and now let's make a sketch by selecting that surface and click F5 to redo for view, undo for view, and from here let's select the outside diameter, convert it to a construction line, draw a skirt and give a value for the cut and make it cut through all, and save that one. And let's open this skirt axis and hide the work plane, make it invisible, and click on save. Now we have the skirt axis with two openings, as you can see. Here we have that opening on that side and the other opening on the other side. Okay, now as you can see in this part of tutorial, we create the washer on the skirt axis. We add the nozzle on the bottom head. Let's take a section, a half section here. We add the nozzle to the bottom head, and we discuss how to calculate the projection for this nozzle from the seam line of the head, how to add this nozzle as a nozzle from plate. After that, we add stiffening grips for that nozzle inside the skirt opening. We add 4 skirt vents, and we learn how to make a copy from a part and add it to the same parent. Okay, inshallah, on the third part, we will discuss the other types of nozzles on the shell and on the top head. Thank you for your time. Have a nice day.